All right, let's get started. We're going to talk about succeeding with Xamarin. How many of you are doing Xamarin actively? That's quite a few, I'm sorry. I'm just kidding. I love Xamarin. I've been doing Xamarin for a long time, probably since the beginning of the first release of Xamarin. But lately, I've been looking more into alternatives, and we have a big project at work where we've done Xamarin for the last 4 years, and we just recently decided to rewrite the entire app in native. So I've got a lot of learnings over the years, and I'll talk a little bit about those things that made us change into native programming instead, and some of the problems that we had early on that would probably had made our decision to go native not ever come up. So we would probably be sticking with Xamarin if we'd follow some of the examples that I'm going to talk about here today. But before we get into that, my name is Filip Ekberg. I'm a Microsoft MVP. It doesn't mean that I'm employed by Microsoft, which you will probably tell after this talk, because I'm going to talk a lot about interesting things in regards to Xamarin and some of the problems. If you have any questions, please do ping me on Twitter or call out my name here, and I'll try to answer anything that you might ask. All right, so I like to look at this at the perspective of failing with Xamarin. So one of the problems that I've had lately is that there are so many different devices out there that it's really hard for us to build great apps for all the different platforms. And this app that I'm working on currently, we've been developing this code base for the last 4 years. And one of the problems, the main problem with the app is that it's really hard for us to find people. So finding people, if we do that and we find the correct type of developers, it makes it a lot easier for us to build the apps. But the problem is that we find C# developers that know a little bit about the native platforms, or we find native developers that know nothing about C#. And we kind of need to bring these two paradigms together and build better applications. So if we look past the people problem, which is the biggest problem, then we've had other issues with Xamarin. One of the problems is the tooling itself. We've had, I don't know if you've experienced this, but every release, even if you're on the stable channel, it feels like it's an alpha version. We get random crashes on the platforms, especially Android, and it feels like we were kind of in a public beta testing scenario. So I'm not trying to be discouraging here, because I think Xamarin is one of the best cross-platform toolkits out there. But one of the first things that I get asked by a lot of developers that think about jumping on Xamarin is that, do we really want to jump on this technology? What are some of the problems that you've experienced doing real-world projects? And I've been doing greenfield projects where we've been really successful with Xamarin. And I've done this long project where we kind of failed and we need to jump on something else. So I'll talk a little bit about the problems that we've had. But before that, not everyone in here is doing Xamarin. So Xamarin is a great way for us to take some developers that know a little bit of C#, teach them a little bit about the native APIs, and they can build awesome applications. That's the promise of Xamarin, that we can just build an app and it's available on every platform. So all that we need to do is just know a little bit of how iOS works and how Android works, and a little bit of C# and we'll be successful. At least that's the idea. I don't know how many of you have felt that it's that easy. It's probably becoming easier with things like Xamarin.Forms, but you still need to learn a lot about the native platforms before you can feel like you have a first-class application. So how do we build a successful app? Well, obviously, you need to have a good idea. You need to build something good. If we look past that, we need to share the right amount of code. So one of the biggest problems with building things cross-platform is the level of code sharing. How much code do we share among the different platforms? Does it make sense to have something in the shared layer that's not available on all the platforms? If it's not, then why do we build something cross-platform to start with? So that's one of the things you need to think about when choosing a toolkit or when using Xamarin. And of course, we want to minimize the app size. One of the most common complaints that we get with the app is that maybe it's 50 megabytes, and now that we built it in native, it's 2. So that's kind of a big problem. I'm not blaming Xamarin for all of that. Mainly, we are using a lot of NuGet packages. So one of the things that .NET developers love to do is to just bring in a package that solves all our problems. But on Android, again, what happens is that it needs to bundle everything with the application, which means that the application itself grows a lot. It can't really strip everything out from those packages. So every time you link a library, your application is going to grow a lot. And especially with things like .NET Standard, where it brings in the entire .NET framework in small little pieces, that kind of tends to make the application quite large. So I'll talk a little bit about how we can avoid that and how we can make our applications a little bit smaller. And then we want to optimize the applications for speed. And I'm not only talking about the application itself being performant, because it's a native application, right? So when we build something in Xamarin, we know that we have a native application. I'm talking about the startup times of an application. So Xamarin has been doing a lot of work on startup performance. On iOS, the application started really quickly, even if it's Xamarin.Forms. On Android, it doesn't really start that quickly. So we've seen older Android phones that start our app in maybe 15 seconds, where iOS takes maybe half a second. So they have a lot of work to do, especially when it comes to Xamarin.Forms. But they are aware of all these different problems, and we can just wait for them to fix it and focus on things that we can fix in our code. So I think most of you have seen this image before. This is the kind of the idea of Xamarin, that we can share a lot of code in our shared application logic layer. So if we focus on sharing the right amount of code, the idea is that we have this pretty small native layer that just allows us to build and bundle the application that runs on the platforms. And then we have a lot of shared code that kind of solves all the same problems across the different platforms. In reality, what I've seen happening is that we kind of end up in this scenario here where one of the platforms tend to be a little bit larger, and we build things in, for instance, the iOS project. So a funny story here is that my product owner uses an iOS device, which means that everyone needs to focus on iOS. I usually joke about that. One day he's going to watch one of my talks, and I'm going to be out of a job. So what happens in most cases is that we have one of the platforms that kind of grow a little bit more than the other. So we add things, for instance, to Android to work with NFC, or we add things to iOS to do things like with Siri, which is not available on Android. Similar things are available on both of the different platforms, but does it make sense to put that into the shared application logic layer? Well, a lot of people would probably say that it is, but you end up in a situation where you have all these different abstractions where it doesn't really make any sense. And we have to think about that when we're writing code that runs on these different platforms, a lot of people have older phones, and we need to think about all the CPU cycles that need to run through our code. So to avoid this, we need to know about and understand why it's so hard for us to do code sharing. Why is it so difficult for us to do the right amount of code sharing across the different platforms? We know that we want to build an app, and we want to build this app using Xamarin because there's no other alternative out there that's good enough. We can look at things like React and PhoneGap and other cross-platform toolkits, but the problem is that they're not as close to the native platforms as Xamarin. So Xamarin is one of the platforms that or toolkits that are bringing you closer to the platform. So you're true to the APIs. If you know Android development, you'll find yourself familiar with everything. You just need to know a little bit of C#. Right? Same goes for iOS. So the reason that it's so hard for us to share code across the different platforms is mainly because we have all these different permutations of devices. We have everything from these large Surface hubs to HoloLens, to the watches, to tablets, to refrigerators, and whatnot, right? And even the latest Samsung TVs now using Xamarin.Forms Xamarin as the go-to framework to build apps for the Titan TV, which I think is pretty cool. But that means that we need to think about all the different things that we want to share across these different platforms. If we have an application that needs to run on a watch, as well as on a phone, do we really need to share all the same amount of code? So the app that I'm working on is for public transport. The same app that I worked on last time I was here and talked about Xamarin. One of the issues with this app is that we have a lot of people running different devices. We have small phones, old phones, and since it's public transport, we can't really say that, well, you need to run Android 6 or later, otherwise we're not going to support your platform. It doesn't really work like that. But then again, we want to innovate, and we want to build things that are fun and that helps people to commute to work. So we might want to build something for the iWatch or for other types of wearables. It doesn't really make sense to maybe bring that into the standard projects or to share any code at all for those projects, right? So in some cases, it makes sense to not share any code, but we try to bring things out into NuGet packages and share as much as we can. But we need to think about when it makes sense and when it's not. So you kind of feel confused, right? Because we want to share code across different platforms, and we want to build applications that are quicker to build, because that's kind of the reason why we choose Xamarin, because we want to build an application quickly. We don't want to build an application that's slower than if we built it using Java, Kotlin, or Swift, or Objective-C. We don't want to kind of build the application with any limitations. So what we do is that in order for us to kind of reach a good amount of code sharing is to think about how we can abstract things in our applications, where it makes sense. So we want to introduce patterns and practices to make it easier for us to introduce things in our code base, to make it easier for us to introduce new systems if we need to. So it's funny because I always have Windows as well in my examples, but is anyone in here building Windows apps? One? You're scared of raising your hand, sorry. Not a lot of people do build Windows apps. I would love to build UWP apps, but not a lot of people do. So that's kind of, one of the first things with Xamarin when I started out was that the promise of you can just add any platform. And one of the first things that the product owner asked me is, well, we built the app with Xamarin, we built it for iOS and Android, now we want to add Windows Phone. I told him, well, if you didn't build everything in the native layers using Xamarin, it would have been very easy for us to just introduce a new platform. But fundamentally, we had kind of an incorrect architecture. So we had a lot of code like this here inside our native layers and just shared code for things like service interactions and talking to the backend and maybe models and view models, which means that introducing a new platform is really hard. Right? So in this case here, we're kind of not sharing the right amount of code. And you can see here that kind of the box is bleeding to the shared code layers. And what I mean by this illustration here is that sometimes you see that you use these shared projects with Xamarin. It's this idea of doing kind of file linking during compile time. So it brings in the files into the project that it compiles. So it compiles as a part of, for instance, the Android or iOS project. That means that it can access things on the native platforms like the GPS or other things without having any references to that inside the shared project. Now, what I see a lot of developers doing is to have compiler directives in here. So they say, well, if this little code snippet runs on Android, we run this thing here, or if it's on iOS, we kind of do another thing. So that's kind of when it bleeds into the shared code and when you try to write platform-specific code in your shared layers. That's kind of the wrong way of looking at it. So what I tried to do, and I think most developers through the years have tried to do this, is to just add more layers in our application. We just add some things like, well, let's start at the bottom. We add a .NET Standard library. We now have support for .NET Standard libraries and .NET Core in Xamarin. The support is pretty good. They're working on it. So that's where I would put my services and interfaces and abstract classes. And then on top of that, we can add a shared layer that implements common things. So if the implementation is similar on iOS and Android, how about we just build that implementation once? But the reason that we're not putting that in the .NET Standard library is because that could be consumed by things like the web backend or other types of platforms. And then I want to challenge the idea of having a shared UI. So sometimes we want to say, in a little bit more abstract manner, to say, well, this is my UI. I'll just let the platform decide what this looks like. So of course, I'm talking about Xamarin.Forms, and that allows us to specify our UI using XAML to say, well, I want a layout that allows me to position something in the center of the screen, and that'll just render properly on the native platforms. We did an experiment with that in the app that we built, which kind of was a mistake as well. Funny story, so what we did was that over these 4 years, we've changed a lot of developers, because it's really hard to find good people, right? But we still failed with the application, and I'm the only one that's the same that started with the app. So I think the problem might not be the people that we changed. Just kidding. So, and then of course on top of that, we have the native layers, which could be things that are very native and very specific to that particular platform. So we have things like NFC now works on both iOS and Android. They just released they opened up, rather, to use the NFC chip on iOS more than they had before. So now we might want to do that in the native layer, or we bring that down into the shared and common implementation, if the implementation is similar enough. Okay, but I'm not saying that more layers is necessarily better, because a lot of people, especially if we try to work with like microservices and that kind of thought, I see a lot of people just add more layers, and we have services and repositories and factories, and there's so many layers. We don't need that, so we want to just limit the amount of code that we have, but still build something that's flexible enough for us to be able to add more platforms and extend the app that we have. Right? So we can do that by introducing a few patterns. Now, of course, we can just, the same with layers, right? We can just throw patterns at the problem and think about how does this solve our current use case. But some of these patterns that I'm going to talk about, they're good enough with the limitations that we have on the platforms. So if you've done native Android and native iOS, you know, for instance, that there's no inversion of control, not real inversion of control, that is. So you can't do constructor injection on Android, and you can't do it on iOS, because the platforms fundamentally work differently than you would, for instance, say with a web application where you could do constructor injection, because the runtime supports it. So why do we want to do this? Kind of obvious, because we want to make our code easier to work with, and also we want to make it more testable. So one of the problems that we've had as well is that we want to write tests. We want to have good code coverage, but I don't think there's a single unit test in our application. Again, I don't think that's why we failed, but we have fundamentally the wrong architecture, which means that we built everything inside the native layers. So just avoid that. If there's one thing that you can take away from this talk, it's to avoid adding too many things into your native layers. Try to think more about the patterns and practices and the layers that you can add to avoid adding too much code that's repeated across the different platforms. Just an example, now this is not the best example, but we have this activity here on Android, and we have this thing in the middle here that's kind of saying, well, if the user is logged in, I want to transition to somewhere. And often what happens is that this here, it would be silly to break this out into common code and have the same kind of code for the different platforms, because that would add even more code to solve this little problem. But what happens in a lot of cases is that, well, this block here grows a lot, and you want to log to the database if the user is not logged in, and you might want to track that using Google Analytics, and you might want to do a lot of more things if the user is not logged in. So what happens is that you probably have the same idea on both iOS and Android, so how about we kind of break that out? We decouple this from the app, from this activity here, to make it easier for us to work with, right? So you can't really test this here, which is a good way of thinking about things. How do we test this without running the application? Right? So we want to decouple this, which means that we want to break that little thing out. We want to add more code to solve the same thing, but in the long run, we want to make it easier for us to introduce new functionality. Right? So this is an idea. We can add a view model, which is kind of something that we've seen if we do in Xamarin.Forms. And it's one of the patterns that they try to do on the native platforms now as well. If you've done Kotlin with Android, it's a very common pattern as well to do MVVM. So the idea with MVVM and view models is that we write our logic in an abstract manner. So we get some settings thing here that can check if we're logged in, but we don't know about the implementation. So someone else injects the implementation into this view model. That allows us to still check if we're logged in. And then, of course, we could fire an event if we want to navigate somewhere, and the native platform could listen for that event. So it's pretty simple. It's a lot of code to solve the same problem. But as I said, in a lot of cases, what happens is that this grows out of proportion. And again, in the app that we just built, we had the idea of splitting everything into view models, and we had this guy that wanted to do proper MVVM using Xamarin.Forms and view models. And when he finished one of the things that he built, we had like a view model that was like 500-600 lines of code. And I'm like, that's not better than having 200 lines of code in each project. So don't overdo it, right? So put the right amount of code into your shared code. You can still write bad code if you're doing it shared, right? So, but in this case here, how do we do something platform specific? Like, I want to do NFC, for instance, or I want to talk to the GPS. Well, we can still be shared. We can still write shared code that's a little bit specific. You saw that we can inject interfaces if it's available on that particular platform. I've got an example of one of the things that we're doing in the app or that we did before. So in this case here, we get an HTTP response message. And a problem with Android is that if you're receiving gzipped or deflated data over the web, the built-in HTTP client with Xamarin doesn't support decompressing that out of the box, which is kind of this fundamental thing that every HTTP client should support. So just for Android, we need to manually decompress the data. So this is a shared layer where we say, well, when this is compiled for Android, I want to decompress this manually. Now, again, what happens in a lot of cases is that this grows as well. So you want to add a little bit more to Android, or you want to add a little bit more to the other platforms, and you end up having platform-specific code in your shared layers. So this is sometimes a good idea, but a better idea would have been to inject like a decompressor interface and have that implementation be in the native platforms. But as I mentioned, one of the great ways to learn is to fail, right? So this is a good way to shoot yourself in the foot in the long run, so try to avoid that. All right, so one of the other patterns that I want to talk about, and I did mention that we can do dependency injection or inversion of control. And we can kind of achieve this for certain things like our own services or our caches or whatever, or view models. But we can't do constructor injection on things like activities and the native components. But for everything else, we can use an IOC container like TinyIOC to allow us to specify interfaces and register types and so forth. And then what we can do is that we can introduce yet another pattern, which is called the service locator pattern. This is kind of an anti-pattern. It makes the code really hard to test, because what we do here is that we say, well, I have a static interface of my service locator, which allows me to, for instance, grab this account service, which resolves that using the IOC container, which would then resolve everything for that constructor, and if the parameters for the constructor have dependencies on other things, it will resolve that and so forth. Let's just have a look at what that looks like. So in my solution, what we have here is an application. It's just a file new project, pretty much. And we get this application thing. It's a partial class. And in the initialization of this here, we can see that it's registering things with the service locator. The service locator allows us to register implementations. It allows us to register instances. And we can see here that even in here, this is an out-of-the-box Xamarin example, and they're doing things incorrectly. What they're doing here is that they're using compiler directives to say that, well, if it's iOS, I want to use the iOS message dialog. If it's Android, I want to register this as the Droid message dialog. Actually, what they're saying is that for every other platform, they're going to use the Android message dialog, which means that if we reference this project using UWP, this would break, which is not really good, right? So that makes it really hard for us to share a lot of code. What I would rather do is that I would take these lines of code here, and I would move them into the native layers. It's OK to do things on other places as well. So we could register that, for instance, inside our main application. And now for Android, it registers that message dialog properly. That's a better way to do it, in my opinion. Now, what happens here is that it's registering these things using a singleton, which lives for the entire lifecycle of the application. And I can grab that instance of anything, like the account service. We can see that, for instance, in the splash screen activity. What I'm doing here is that I'm saying, well, I want to get the service, which is the iAccount service, and then I can save some account into that. Now, again, how do you test this line of code here? It makes it really hard for us to write a test here, right? Because we're writing code in here that's depending on things outside of its own box, which makes it really hard for us to test it. So we're kind of back at square one, but the native platforms don't support constructor injection, which means that this is the best that we're going to get, unfortunately. And of course, we can save something in here for the service locator, and then I can grab that same thing. We can run the app. I'll show you what it looks like. And for the login activity, we'll see here that it's going to grab that same account service and then load the demo account and show that in our application. So we'll see that starting up here shortly. Hopefully. So that's one of the other problems with Xamarin. It takes forever to build the apps. This is just a file new project. I don't think I have anything in particular set up. So you can see here that it says sign in as Filip. So the splash screen used the service locator, which resolved something in the IOC container, which could have lived in a view model, and so forth, right? So the next step would, of course, be to go into the splash activity and try to break this out into somewhere else that's common for both iOS and Android, because now this code only lives on Android, and it's not the same on iOS, which is kind of one of the problems, right? So that's one of the issues we had when we built the app. It's that we tried to build an application that's graphically awesome, at least 4 years ago. I wouldn't say that it's awesome anymore. But the idea was that it's so heavy on the graphics that it's really hard for us to build something that's shared for iOS and Android. So what happened was that we built this application. We have these native layers, and we built all the code inside in 2 places. But we're using Xamarin because we can share a little bit of the code. But that means that if there's a new screen in the app, we have to build the same thing twice. I'm just happy we didn't introduce Windows Phone, because that would have made a lot of work. Actually, that would have been good. I'd probably be employed for the next 10 years. So the service locator is a great pattern. As I mentioned, it's an anti-pattern, which pretty much means that after a while, you're going to feel like, well, this is not really good, because now we have a lot of spaghetti code. And no one wants to have that. So if we think past the idea of, well, we can try to move things into our view models, and we can move things from our activities and just bootstrap small things in the activities or in the view controllers, and maybe we can think about adding something like Xamarin.Forms. So I mentioned that we tried to do this because we got tired of just re-implementing all the UI for each platform, even if we used Xamarin, right? So we wanted to, for smaller things that we didn't really care too much about, we wanted to introduce Xamarin.Forms, because what happened was that we can specify the UI once, and it's just replicated across different platforms. So we did that using even before Xamarin introduced support for it, which is kind of living on the edge. Because when they do release things, it's not necessarily stable. So jumping on something before they even release it was kind of interesting. So what happened in our case was that, well, we can try to move a lot of shared code into the shared layer. We add this Xamarin.Forms layer, and we try to stay true to, well, we don't want anything to leak beneath this here. So we have shared code that allows us to do things like common implementations and services and interfaces. And then we have Xamarin.Forms for common UI, and we have view models in there and run MVVM. And then we just have this small little layer on top here. Now, that's a great idea if this works. It did work for certain platforms, or certain phones, I should say. What happened was that when you start Xamarin.Forms on iOS, nothing can really be interpreted in runtime on iOS. Everything needs to be be ready at compile time. So everything with Xamarin.Forms is compiled into a native application on iOS. But what happens on Android is that they don't do that. So a lot of the things with Xamarin.Forms and in Xamarin in general, they interpret a lot of things and run up this runtime on Android, which means that the application will be slower if you run Xamarin.Forms on Android. And especially in our case, since we do public transport, we have people running Android 4 on, I don't know, the Samsung Galaxy S Mini, which is maybe 5-6 years old. That's kind of a problem. So when doing this thing called Xamarin.Forms embedding, what happened was that we had this one button in the app. You press that, it runs up Xamarin.Forms. Everything is MVVM, everything is beautiful, the code is good, but it takes forever to start up this page, so people kind of get upset. So we have to redo that as well, right? We have to redo that either in Xamarin native, or we have to do that in native code. So if you want to do this, which I think it's good if you run an application or write an application that's only for newer phones, doing Xamarin.Forms embedding is it's a pretty good way to go. We can say here, in this case, we have this Xamarin.Forms page. I can either create a fragment, I can create a support fragment, I can create a view controller, and then I can embed that into my applications. And this allows me to access everything that's in the capability of Xamarin.Forms. So I can do things like MVVM, using MVVM toolkits that we might have seen before using Xamarin.Forms. And in this case here, we have this Android activity here, and then I'm simply just embedding that into the app. It's pretty cool. I think this is a great idea, unless you work with older phones. And of course, the same works for iOS. So let's just have a look at what this looks like. Instead of just looking at slides, let's look at some code. So kind of the same application. What I've done is that I've just introduced some Xamarin.Forms. So I have this UI project here. We have this My Page, which is simply a button which will be vertically aligned. It'll update the text if you click it. And of course, this code here could be improved as well. We could do MVVM, but that's kind of overkill for a little button. Now, if we go into the Android project, we'll have a look at our main activity. When we click the About tab, what it will do is that it'll initialize Xamarin.Forms to the current context, and then it will return a new fragment which it will navigate to, because this here is a fragment pager adapter. And that's all there is to it. So this is a way for us to introduce Xamarin.Forms into the app. Let's just run that and see what it looks like. And I've talked to Xamarin a lot about this, that there's a problem that it takes a long time to start up and to run this on Android. And they are working on it. They're going to try and do the same thing that they're doing for iOS. So click Not Now here. And when I click About here, it will initialize Xamarin.Forms and then render that fragment. So it's super quick on my machine here, but if you run that again on an older phone, it'll take a little while. But not on iOS. So this here is Xamarin.Forms. This here looks like an Android button, right? So we could add elements here. We could have theming inside Xamarin.Forms, and we could make this look like a beautiful Xamarin.Forms application and kind of be a part of our application. So I think we did pretty well with adding things to our application, the public transport app, that people didn't notice on your phones that they were transitioning into Xamarin.Forms. There were a few gotchas that, like navigation and toolbars and things, were hiding when you transition into one of these fragments. It didn't really fit into our architecture, but once we got the hang of that, no one knew that they were transitioning into something that's shared across the different platforms. But one thing you need to think about when doing this is that if you add too much code now into your Xamarin.Forms project, you trust that Xamarin.Forms have implemented everything properly for every platform, right? So you might experience random crashes on Android. Again, like I bash a lot of Android. I have an Android phone myself. I love Android, but all the problems that we have, it's just Android. I don't know why, but iOS seems like a much more stable platform in general. All right, so we've added Xamarin.Forms in here, which means that we can now build the UI and we can add things in here, and it should be visible on all the different platforms. And of course, we have the same on iOS, so we can run this project. Let's run the simulator. You can see here that we have this tab bar controller. What it's doing is that it's creating a navigation page, so we get that nice navigation top bar. Then it's sticking My Page into this, changing the tint color and changing a few things. And then it's creating a view controller and sticking that into the list of tabs that we have in the app. So once that's started, we can have a look at that. We can just jump to the next thing, and we'll look at that once it's started up. It takes a while to start the simulator. So now the idea with this is that we can now kind of abstract the UI that we know that's going to be exactly the same on the different platforms. And we can stick view models into that shared project, which is Xamarin.Forms, the Forms project or the UI project. But those view models could be used inside our activities and view controllers, right? So they don't have to be sticking to the Xamarin.Forms views themselves. All right, so let's jump onto the next cool thing that we need to use. So now that we're doing Xamarin.Forms, we can do something called the dependency service. The dependency service kind of solves the same problem as the IOC container. It allows us to say that, well, in this case here, we have an implementation of the account service, and this will resolve the interface here. We'll resolve this iAccount service interface, and when we ask for that somewhere in the app, it will just know what to get, right? So we can do that instead of specifying things using the IOC container ourselves. Again, this is also an anti-pattern, but It's what you get with the platforms. Then there's one more pattern I want to talk about, and that's messaging. And Messaging Center is one way to help us solve that. Is everyone familiar with things like event aggregation? The idea of distributing a message inside something, someone outside listens for this and acts upon that message. So when I click the login button here, the idea is that the activity or the view controller listens for that message that you're now logged in, and it can handle that properly, right? So for instance, what I can say here that, well, I want to subscribe to the login view model, and then when you get that message, I want to fire off a new activity. And of course, we can just send that message inside one of our view models, right? So again, let's look at some code. So kind of all of these different things end up being this idea of you get some patterns and practices and you try to apply them and you try to share the right amount of code. But honestly, it's really hard to kind of say this is exactly the right amount of code to share in your app. It really depends on what kind of app you're building. So we can just look at this iOS app that just started. It doesn't look as good. What's interesting here is that this now runs on an iPhone X, and I created these projects. I think they're built using an older version of Xamarin, so before the iPhone X came out. And what I wanted to do was that I wanted to feel what it's like to upgrade an app using Xamarin. So I just rebuilt the app using the latest toolkits, and the app no longer looks like it did a year ago. And that's kind of the story with Xamarin. A lot of the cases, what happens is that you end up having this application that you need to you maintain, and then you upgrade to a later version of Xamarin, or there's a new version of iOS or Android, and everything just breaks. Would probably be the same with the native platforms. So I'll click About here at the bottom, and we still have this button here that says Click Me, right? So that's a Forms demo. Now let's look at the Messaging Center. So kind of the same idea. Inside my UI layer, I have a view model that's called a login view model. Now I'm starting to think about how do we properly move things into view models and separate our concerns. What I'm doing here is that I'm saying that, well, when you click the login button, so I'm doing this command pattern. So when we fire the login command, I want you to get the account service and save that account that we currently have, which will set the username that I entered into my text box. It will run this messaging center thing and say that, well, login completed. It will pass this view model into whoever listens for the message. So if we put a breakpoint in the Android project, we'll go into that activity that listens for it. I have a login fragment activity here that says, well, I'm going to subscribe for the login completed, which is a login view model. And when I get that, I'm going to just transition somewhere in the app, right? So that's pretty much all there is to it. So let's run this and see what happens. So of course, we're not going to get away from having a little bit of code in our native layers, but the idea is that we try to write code that's pretty much shared across the different platforms. So I click Sign In here. This is now Xamarin.Forms. I'll click Login. You'll see that we get this inside the Android project. We got this event. We can see here that the object passed here is, in fact, containing the username Filip that I just wrote. And then I'll just release this here. I'll go to the About tab here and just Filip in the middle. That's because if we look at the native layer, or the Xamarin.Forms layer, sorry, I have a view model, or view itself, called MyPage. And what it's doing is that it's grabbing that account service. It's grabbing the account that I saved when I logged in. So it's now kind of separated from each other. So my page doesn't know anything about the login page, and the activity doesn't really know anything about what happens inside those fragments, but they can cross-communicate using these events, which means that it would be super easy for me to introduce the same functionality on iOS. And ideally, what happens is that the only thing that you need inside your native layers is to, for instance, how do you transition somewhere? If you want to do something in particular with that data from that message, how do you transition? Now, another idea would be that inside our view model, we would say, well, instead of sending the message, we could say, I just want to navigate somewhere, and someone else takes care of that navigation. For instance, on Android, we now have the navigation host, and on iOS, we have a normal navigation as well, right? So that kind of makes sense. And I mentioned before that we have this dependency service that allows us to now grab dependencies that are specified using this attribute instead of having to specify that using our IOC container. So if we look at our account service, all that I've done is that I've said, well, this is a dependency call for account service, so it'll resolve that interface. And then inside anywhere in the app, I can say, well, I want you to give me an implementation of the iAccount service. So I don't need the service locator. This kind of acts as a service locator for me. Okay, so we're kind of getting to a point where we reach something like an MVVM pattern. So the idea of an MVVM pattern is that we want to get navigation, we want to get event aggregation, which is kind of that messaging center that we just looked at, and we want to get dependency injection. But we also want to get things like automatically resolve things like the view model for a particular view. I want to say that transition to this view here, create the view model for the view itself, inject the view model onto the view, and create everything that the view model needs, right? So there are, of course, tools that we can use to do that. You can use things like Prism, for instance, which is a great MVVM toolkit. So the same idea here is that I have this application, kind of the same. I'm going to close all the other things that I have here so they're less confusing. So I have this application. Let's go into the CS. This is a Prism application, which is kind of just like a Xamarin.Forms application on steroids. So what happens here is that it's registering a lot of things. It's saying that, well, I'm going to grab the iAccount service from the dependency service, and then I'm going to register that inside Prism, which is using AutoFac, as an iAccount service. So it's grabbing an instance from outside of the box, from something that it doesn't know about, and it's registering that instance inside this here. This is just a display that we can kind of use these two paradigms together. And of course, it's registering navigation for the navigation page and login view. And what this does is that it allows us to say that, well, when you're navigating to, for instance, the login view, it's going to know how to set up things, for instance, with the view model. So I have this thing here at the top that says auto wire up view model, which means that it's now going to create the view model for us based on the naming convention. So it knows that this is called a login view. It will then look inside this view models folder and find the login view model. It'll create an instance of that. And this instance here takes an account service into the constructor, which it knows about because we set that up using the DI, right? Or the IOC container. So it'll create the instance for the account service and inject that into this view model here, and then it'll just tie those two together, which means that we can also bind to things using binding for username, binding for the login command, which we could have done before as well, but yeah. And that's all living inside our Xamarin.Forms project, right? So now, if we run this on Android, I haven't really done any changes to the Android project itself. These are all changes just inside Xamarin.Forms. Which is kind of the idea, I guess, with Xamarin, that you want to change things in one place and then just have that changed across the different platforms. So we would kind of get this for free on iOS as well as Android. Let's see if it deploys. Click sign in here. Hopefully this is the latest app. Yep. Okay, all right, Filip, and login, and we'll see that that worked. So I'll put another breakpoint in here. It's a little bit too quick. Because what happens here is that I want to display that it actually creates the view model for us. As you'll see here, it injected the iAccount service as well as when we click login here, it'll fire that command. So just tie everything together for us. So that's pretty neat. So kind of what we want to do in order for us to be successful with Xamarin is to try and apply these different patterns. We want to try to bring things out to view models when we can. We want to add things like Prism or other toolkits that allows us to use navigation and event aggregation and dependency injection and not worry too much about those things on the platforms, unless, again, we work with older phones. All right. So now, hopefully, the application is a little bit more testable, which means that we could potentially write some unit tests. I don't know if that would make any sense. So I don't know if anyone in here is doing automated UI tests using Test Cloud, but we tried to do that a few times. Guess what? We failed. We're not failing everything, but what happened with the UI tests were that they took so long to run. So it would be quicker for us, or cost less, to hire a manual tester to run through the app than it was for us to wait for feedback from UI tests, right? So, because time is valuable, and waiting for something to run in the cloud that's waiting for a device to be available wasn't really the best approach. And then a manual tester finds things that these UI tests won't. So things like, well, this font size looks a little bit odd. The margins are a little bit off, which arguably the product owner has told the developers, well, if you just run the app, you'll see that these are all problems. But most developers don't seem to run their own code. So unless, well, we have CI, right? So someone else builds the code. If it builds, it works. If we build using MVVM, and if we break out these things, it would decouple the code. That kind of means that the application is hopefully more maintainable. If we do that properly. So we really try to do this. We try to rewrite a lot of things in the app and make it more following MVVM patterns and looking more like a proper application. But the fundamental architecture was so heavily bad that was really hard for us. It took a long time. But I've seen Xamarin projects that are really awesome that apply these different patterns, and I've seen Xamarin.Forms applications that perform really well and look really great. And one way to solve this is, or to make it faster, is to apply ahead-of-time compilation, which you would probably think that's turned on by default, but it's not. So what you can do, this is for Android only. Ahead-of-time compilation means that it takes all the code that we have, all the .NET code. So on Android, it takes the .NET assemblies and bundles that as a part of the APK that you get when you compile a project. So if you bring down a project from Google Play and you just rename it to .zip, you unzip the file, you'll find all your different .NET DLLs. If you turn on ahead-of-time compilation, it will still have all the .NET DLLs, but it will also have native compilation for all your code, which means that the application is going to be larger, but it won't need to resolve things from those native, .NET assemblies in runtime in the same manner. So what you can do is that in Android build, you turn on this little flag called enable AOT, and then you go into advanced, and you say --AOT is equal to full, and you need to make sure that you link SDKs assemblies only. If you do all that, your application is going to be a little bit larger and potentially a little bit quicker, especially on older phones. And then one more thing that you might want to turn on is this one here, embed assemblies in native code. That means that it'll take all the .NET assemblies, it'll compile those into native code again, which I would expect the ahead-of-time compilation would do, but they will no longer be available in your APK. So when you decompress the APK, there will be no way for you to look at the .NET code that you had, which is great. But in the latest version of Xamarin Studio and Visual Studio, that broke this. So when you publish the app to Google Play or App Store, when you launch it, it'll just crash. It'll compile just fine. So we kind of noticed that pretty late because, well, developers don't run their own code. So turn those two things on. There's a fix on GitHub. They've deployed packages or in VSX files to solve this, because it's kind of a priority. I think it's only enabled in enterprise version of Visual Studio as well, so it's kind of important to them for them to fix that. If you have both of them turned on, the apps will be larger, but they will be faster to run, which is really important. And then another thing, you might want to change the HTTP client implementation as well as the SSL TLS implementation, because the native one is a lot faster than the Xamarin one. All right. So hopefully we feel a little bit more happy about doing Xamarin, right? So we want to try and share a lot of code. The goal with this is to share the right amount of code in our applications, which is really a hard thing to put your finger on. How much code do we need to share? Well, that kind of depends on the application. In a lot of cases, it doesn't make any sense to share a lot of code. And in those cases, it doesn't make sense to maybe build the app in Xamarin. And we choose to go over to native code mainly because finding native developers is a lot easier than teaching C# or native developers how to build Xamarin applications. But if you know Xamarin and you know the native platforms, you may build awesome applications. So we kind of end up with an architecture that looks like this in the perfect situation. We might have a little bit larger iOS project because we have some specific code, a little bit less on Android, and maybe a little bit more on UWP apps because we want to have support for the Surface Hub and for smaller devices as well. And of course, we have the shared UI layer, and then we have the shared application logic layer, which could be .NET Standard. And it's kind of obvious that we need to build something great, so let's just jump ahead of that. We've talked about sharing the right amount of code and that it's really hard for anyone to say how much the right amount of code is, but I've shown you some patterns that you can apply in your code to make it easier. Just think about how do we decouple the app? How do we make it testable? How do we make it more fun to work with? And then I did the opposite of talking about minimizing the app size. I talked about making it larger, but to make it run faster. So you're going to have to choose, do we need to have a large app or a fast app? And on iOS, you can turn on things like optimize PNGs, which means that it'll optimize all the images in the app, and that'll kind of reduce the file size on iOS. But the first test that we're doing now that we're rebuilding the app using native code is that we are looking at the startup times, we're looking at how large is the app, and mainly the feeling of the application, as well as development environment. When I build the Android application, the APK is 2-3 megabytes now, compared to where a blank Xamarin app is maybe 15-20. And when I build the app for Android and deploy that to my device, that takes maybe 4 seconds with native. It takes maybe 15-20 seconds with Xamarin. So those are some really interesting things that we're finding when we're jumping on this train. But it doesn't mean that 4 years from now, this would have been the right decision, right? So just because we jumped off the ship doesn't mean that it's not the right one for you to choose. So just to wrap this up, I think Xamarin is the greatest toolkit out there for cross-platform development because it's true to the APIs. It keeps you close to the native platforms. You can interact with the iOS and Android APIs, and you can build applications that are really awesome. But you need to think about the limitations of platforms. You need to think about how do I build applications that run on all these different permutations of Android, because that's the biggest problem with Xamarin. All right, thank you for listening to me. It's been a pleasure. If you have any questions, just hit me up on Twitter, and don't forget to leave a vote when you leave. All right, thanks.